here is magnified. So what kind of image is formed? Magnified. Real and inverted again. Real and inverted. Now let us see all the cases once again. See, when the object is at infinite distance, very far from, you got a very diminished image. As the object is coming closer, you can see that there is an increase in the size. May not be of this much, but there is an increase in size when compared to that here. And still when the object is coming closer and exactly when the object is yet C, that is center of curvature, we get the image equal to the size of the object. That means of same size. Here also real and inverted. You can see that the image is below. You can see that the orientation or the head and tail are got inverted here. Right. And then next object is still more further moved towards the mirror. So you can see that the image formed is magnified. So see, slowly as the object is coming closer, image is moving farther. As the object is coming closer, you can see that here the image was here, object was somewhere here. Now the object is closer, image moved away from the focus. Now object is at the center of curvature, image is also at the center of curvature. Now object moved between F and C, and now this crosses C, that means beyond C. Image, where is the image formed? Image is formed beyond C. You have to remember all these locations, then only you can appropriately draw the diagrams, adjusting the scale properly. Okay, so this is the case where you got the magnified image. So where will you get the magnified image? When the object is between F and C. When the object is between F and C, that is the focus and the center of curvature. When the object is, that means in case of a concave mirror, when the object is between F and C, then you will get a magnified image. The question can be asked even this way, like when will you get the image equal to the size of the object? So we will get the image equal to the size of the object when the object is yet center of curvature. Yet center of curvature. So here it is diminished, here smaller in size, here almost equal in size, and here is the magnified image. So pause the video for a moment and please copy this. We have some more cases. Done. So now when the next case is, see, we started moving from infinity, that is missing now here. Case 1, after that to a finite distance beyond C, and yet C, object yet C, of course, image is also yet C, and now within C and F, object is between C and F, and now what would be the next one? Yes, next one is yet F. If object is yet the focus, so take this as concave mirror. Now object yet F. This is the case 4. Now this is the principal axis, suppose pole F and C, center of curvature F and pole. Now this is the object. This is the object. Here you can see that one ray which is falling parallel to the principal axis. How are you going to draw the other ray? How are you going to draw the other ray? You can't draw passing through focus. Okay, it will it will change its location. So I'll take it like this. See, I'll take it like this. Let me draw it along the normal. Normal passes always through the center of curvature. And what is the third rule? Whenever a ray is incident along the normal, it comes back along the same path. So let me take this ray now here. This ray here. And now therefore the reflected ray also comes here like this. The reflected ray passes through the center of curvature along the same path. And here what is the rule? It should pass through the focus. It should pass through the focus. Now if you can see that these are parallel to each other. These are parallel to each other everywhere. So that means two parallel rays are emerging out. Two parallel rays are coming out. So where the image can be formed? So again in mathematics we learn two parallel lines can meet only at infinity. So if at all the image is formed, image is at infinity. It is at infinity. Usually we never say what kind of image is formed there. But from symmetry you can feel that it is again inverted and real. It is supposed to be. Right? But I conclude it with like image at infinity. You get a magnified image at infinite distance. You can't capture the image here anywhere. You can't capture because you can't take the screen to infinite distance. Right? Now, case 5. Right, principal axis, and this is the lens, mirror. This is my case 5. What is the case 5 now? Bring the object within the gap between P and F, or within a distance of focal length, even less than focal length. F, P, C. Now this case is object is here. Object is between P and F. Now again one ray here. So one ray passing through this one. Let us take this one. Normal. Along the normal. This case also we are taking along the normal, right? So this case also we are taking along the normal. So this is the ray which is incident. Now after reflection, this passes through this. Now here after reflection, it should pass through this. They are diverging away. So if you extend the lines, you can see that this line goes here and this line goes like this. As the distance is increasing, we can see that the gap is increasing. So thus, then where the image is formed? There is no point that these two will go and meet anywhere. Here at least we can say theoretically that two parallel lines meet at infinite distance. So therefore two parallel lines may form an image at infinity, but here these two are diverging rays. This is the case where we have studied in convex mirror. Convex mirror is not where they seem to be coming out. So here also the same case. Let us extend this to the dotted line. Let us extend this dotted lines like this. See from where they seem to be coming. They seem to be coming from here. They are looking as if, that means when we look at these rays, we feel as if the rays are coming from this point. So therefore here is the image formed. This is virtual image. This is virtual magnified. See, and erect. How the object is like that only. It's not upside down like that. So erect. So virtual, magnified and erect. The image kind is like this. Special case. This is the special case of concave mirror. Where in case of concave mirror, we already said concave mirror is also called as converging mirror or convergent mirror. But here what is happening? The rays are getting diverged away. That means in this particular context, this concave mirror is behaving like a convex mirror. That means diverging mirror. It is behaving as a diverging mirror. This is a very, very special case. Okay, and the kind of image formed is virtual, magnified and erect image. How should you draw this one? like so same one is parallel to the principal axis, the other one where it is not possible to pass through the focus, we are taking to pass through the center of curvature here also. That means along the normal. When the ray is incident along the normal, then the reflected ray also travels in the same path, but in opposite direction. That is the third rule. So we used this rule in these two cases. Right? Is that clear? Now here we can see that the rays are getting diverged away. So now we extended this dotted lines from here. So now you see that as though the rays are emerging out from this point. Hence, we feel that the object is here or there is something here. That something is the virtual magnified direct image formed because of the concave mirror when the object is between P and F. When the object is between P and F. Very, very important concept, can be asked as a 4-mark question, that is a set-type question, can be asked each case can be asked as a 2-mark question or can be asked as an objective question or any of the kind. So, but you are supposed to be very thorough with the rules and please use scale and pencil so that you won't find difficulty in drawing the lines straight, so that your images will be perfectly forming at the respective positions. Right, children? So what are the 3 rules that we have taken? All that are revised here. We applied those rules here and then we drew all this. Now I think you can fill the table if it is asked, like if suppose if the object is at this point, at this point, at this point, how the image is formed. Okay, I will post the table to you so that you can fill the table with all these details. Right? Is that clear? Please pause the video for a moment. Draw all these things. If you have any confusion, repeat playing the video and pause at a point wherever you need to think. And then practice drawing the ray diagrams. Without these, you can't do anything in this chapter. Okay? See you again.